All right, so now we're going to learn another theorem about similar triangles. It's called the triangle angle bisector theorem. And what this theorem states is that if we have a triangle, and I'm going to call that triangle BC, and we have in that triangle an angle bisector. So that means that this angle is congruent to this angle here. Then actually what that does is I'm going to call this point B. It divides the opposite sides into two segments who are proportional to the lengths of the other segments. What I mean by that is if I take AB over BD, that would equal AC over CD. There's many ways that you can write this proportion. You could also write it as AB over AC equals BD over CD. But the AB side needs to be, the AB side corresponds or it pairs with the side that it's adjacent to, so the BD side, and the AC side pairs with the CD side. So keep that in mind as you're creating your proportions for this. But we're going to prove this. When we prove it, we're given that AC bisects angle BAD. In order to do this, we do need to draw auxiliary line of EE. And I'm going to connect this line to here as well. I'm going to call this point E, and we create this auxiliary line BE so it's parallel to AC. But before that, in our proof, I'm going to call this angle 1 and angle 2. By the definition of an angle bisector, we know angle 1 and angle 2 are congruent. So then I create that auxiliary line, EB, so it's parallel to AC. All right. And then we have side splitter theorem, because the side splitter theorem states that if we have these two parallel lines, then it cuts the sides proportionally. So EA over BC, it would be equal to AD over CD. That's the side splitter theorem. And then we have parallel lines cut by the transversal BA. Angle 3 is right here, and angle 1 and angle 3 are congruent because they're alternate interior angles, which if we know that they're congruent, then we would know, also angle 2 and angle E, which is this angle up here, are congruent because those are corresponding angles on your parallel lines. Okay, then if we know angle 1 is congruent to angle 2 and angle 1 is congruent to angle 3, then we can say angle 2 and angle 3 are congruent by the transitive property. And then we have angle 2 being congruent to angle E and angle 2 also being congruent to angle 3. So since angle 2 is congruent to both of these angles, we can say that those angles are congruent by the transitive property as well. So what I have right now is I have angle E and angle 3 being congruent, which actually then, it doesn't look like it because I didn't draw this properly, but actually actually makes this triangle here an isosceles triangle. So what that means is that EA would be congruent to BA because base angles of isosceles triangles are congruent. Since it's isosceles, that means that the legs are congruent as well. And then from here, if I know that EA equals BA, then I can take BA and substitute it into my side splitter theorem to get BA over BC is equal to AD over AC, over CD, which is the same as AB, because BA is the same as AB, over BC is equal to AD, and CD is the same thing as BC, just written differently. But we just proved the triangle angle bisector theorem. It's a tough proof to do, but it all stems off of these auxiliary lines. All right, so number 27, we are going to find the missing side. So I'm going to label this side over here that's missing X. And we have an angle bisector, so we can use the triangle angle bisector theorem, which states if I do 4 over this 2, that would be equal to this X over this 4. Cross multiplying, I wind up with a 2X is equal to a 16. Dividing by 2 on both sides, X comes out to be an 8. All right, this next one's a little bit complicated. We are going to draw ourselves a picture. So we have the angle bisector of a triangle. So let's draw ourselves a triangle and an angle bisector. Splits the opposite sides of the triangle into lengths 5 and 6. We know that the perimeter of the triangle is 33, but we need to find the lengths of the other two sides. So what I'm going to do is I'm going to label one side X and one side Y. Perimeter means we would add up all the side lengths together. So if I do an X plus a Y plus a 6 plus a 5, that should equal the perimeter of 33. All right. So let's simplify that equation. X plus Y plus an 11 is equal to 33. And so, and then that would mean if I subtract that 11 over, I get an X plus a Y is equal to a 22. All right. We're actually going to create a system of equations. This is one of our equations using the perimeter. Another one of our equations is using the triangle angle bisector theorem, which states that if I do X over 5, that would equal Y over 6. Now, in order for us to use that bottom blue equation and this new red equation, we're going to need to isolate one of our variables and use the substitution method. So I'm going to isolate X in my blue equation by subtracting Y from both sides, and I get an X is equal to a 22 minus Y. Now I'm going to take that 22 minus Y, I'm going to substitute it in for X in my red equation up here. So I have a 22 minus a Y over a 5 is equal to a Y over a 6. Now I just have an equation that has one variable. I can solve for that variable by cross multiplying. So cross multiplying, I get a 5y is equal to a 132 minus a 6y. I'm going to bring that 6y to the other side, so I have an 11y is equal to a 132. And dividing by 11 on both sides, I get y is 12. Well, now I need to find my other variable, which if I use this equation that I'm boxing in green, I can put 12 in for y here to find x. So x comes out to be a 22 minus 12, which means x is a 10. And that's it for that one. All right, looking at the next one, I'm going to actually have you pause the video because it is very similar to what we just did, except this time we're not given the perimeter, we're given that these two sides add together to get 15. So that's going to be one of our equations instead. All right, so now I'm going to have you go from here using exactly the same method that we did in number 28. Please pause the video and try this one on your own, and then resume the video to check your answers. Okay, solving the system by substitution, I isolated x in this red equation here and got 15 minus y. I substituted that in for x in my triangle angle bisector theorem, and I wound up with this. And then I cross-multiplied to find y. Y was 9. Then I took that 9 and put it back into this equation here to find x. X came out to be 6. All right, that brings us to the end of this lesson.